From the beautiful studios of Way Happy, this is Mr. Meyer in 4.2 trig functions. Yesterday or earlier today, we talked about angles and how you measure them, and you can do degrees, you can do radians, and great. So you know how to communicate with people with angles. Now let's talk about something a lot of people love to do. It's called right triangle trig and trig ratios. So what it is any triangle that you draw, you can, in fact, talk about the sides of the triangle in specific ratios, namely sine, cosine, and tangent, ones you've probably already discovered through your years of math, sine, cosine, and tangent. But we do have three others where they're just the reciprocals. If you just flip those fractions, you would get what we call cosecant, secant, and cotangent. And yes, you need to know them all. Now, these ratios hold true for just triangles of any size, but just remember this is called right triangle trig. So make sure that you understand that this only works with right triangles. Don't ever try this if you don't have a right triangle. So on a right triangle, if you pick one of the angles that's not the right angle, you can usually look at the sides of the triangle. Across from that right angle is always the hypotenuse. So I will always, usually if I'm doing this, I will label the hypotenuse first. And then whatever angle I'm talking about, notice I'm talking about this angle right now. Then next to it would be the adjacent, and across from it would be the opposite. So across from the 90 is the hypotenuse, and that's very important that you always label that one first, and then decide which angle is opposite from the angle you're talking about. That's why we're never talking about the right angle. And next to it means adjacent, so that is the adjacent side. So no matter how this triangle is drawn, there's the right angle. Say I'm talking about this guy right here, then this would be my hypotenuse, this would be the opposite, and this would be the ADJ, right? The adjacent. So you have the hypotenuse, the opposite, and the adjacent. Now look, if I want to change my mind and talk about this angle, all of a sudden, hypotenuse stays where he is, but now you become the OPP, and you become the ADJ, and we are hipsters in the trigster world. All right, special right triangles. For most angles, we're going to need a calculator. But there are two very special right triangles that you know from geometry. One of them is your 30, 60, 90, and one of them is your 45, 45, 90. Now, why are they so important? Because we know the ratios of their sides, right? So if you're talking about a 45-degree angle, also known as pi over 4, then you know who the hypotenuse is, you know who the adjacent or the ADJ is, you know who the OPP is. So with that information, I can answer any 45-degree angle, no matter what their sides are. These ratios will always be true because they will reduce down to that. So if I have a 45-degree angle, I can say that the sine, which is opposite over hypotenuse, is 1 over root 2. So I can be like, sine of 45 degrees is 1 over root 2, and you're more than welcome to leave it like that. A lot of people will multiply top and bottom by root 2 and get root 2 over 2. Doesn't matter. Just make sure you kind of recognize both. Cosine is actually the same thing. Adjacent over hypotenuse looks exactly the same. So that's kind of cool. Tangent is opposite over adjacent. And then don't forget secant, cosecant, and cotangent are also there. The other nice triangle that you want to know is the 30, 60, 90. Now the 30, 60, 90 is an important one because, it's also something that I need to have memorized, like the 30 degrees. What is sine of 30 degrees? Well, sine is always opposite over hypotenuse. So the sine of 30 degrees would be 1/2. So now that we got all that in there, you can always draw those triangles and label their sides, or I have this fancy dancy finger trick that I really like, but you got to be super careful when you use it, and it's kind of fun. There it is. So if I wanted you to find the 6 trigs of 60 degrees, you are more than welcome to draw a 60-degree triangle, have the sides memorized, and then just label all 6. That's awesome. But there's also a hand trick, and there's the hand trick. So I want you to hold your hand out, left hand, thumb pointing away from you, I guess, or up towards the sky if you'd like, and looking at your palm. And you label these degrees. It looks like quadrant 1, right? If I were to draw on top of this hand that I have here, it looks like quadrant 1. right? And when we talked about measuring angles, we said this is 0 degrees. We said this is 90 degrees. You know, shooting straight out of the middle is 45 degrees. Well, look at your fingers. Your fingers, each one, if you call the pinky 0 degrees, you call the ring finger 30 degrees, you call the middle finger 45 degrees, the pointer 60 degrees, and the thumb 90 degrees, you have this amazing trig ratio device right at the end of your arm. And so how do you read it? Well, the big trick is this, that you will fold down whatever finger you need, whatever angle you need, and then you look at the fingers that are left. And sine is the number of bottom fingers, square root of the bottom fingers, over 2. Cosine is the square root of the top fingers over 2. And tangent is just sine over cosine, or the number of bottom fingers over the number of top fingers, both of those square rooted. Now, what the heck am I talking about? You're like, what? Slow down. Well, try this. Say I want you to find the sine of 60 degrees. Okay, so what you need to do is look at your hand. You need to fold down that pointer finger so it looks like this. So this one's now folded down. I don't know how I can draw that. Like there it is, folded down, and that's not there anymore. So you've now folded down 60 degrees. If you look at the number of what I call bottom fingers, that's below that folded down finger. There's 3 of them. And that is the sine. If you look here at this formula, sine is the square root of bottom fingers over 2, or root 3 over 2. That's sine. Boom, done. Carrying my trig calculator with me everywhere I go. If you needed cosine of 60 degrees, you would also fold down the 60-degree finger, so your pointer finger, and cosine is the number of top fingers, or above the folded down finger. That is cosine, so it would be the square root of 1 over 2, which sounds kind of funny. Most people will call that 1/2. So the cosine of 60 degrees would be 1/2. How awesome is that? Now, again, could have also done this by drawing a triangle. I could have been like, boom, here's a 60-degree angle. And so if I know my 30, 60, 90 triangle, then I know that this is, I can't remember what they taught you in geometry, but they say 2, and then across from the 60 is root 3, and this is 1. So we said cosine. Cosine is adjacent over hypotenuse. Boom, there it is, 1/2. We said sine is opposite over hypotenuse. There you go, root 3 over 2. So notice this beautiful trick. You can draw the triangle, or you can just use your fingers. Now, if you want, I can try to give you one more. I did ask for all 6. Probably should do it. All you have to know here is sine. The opposite one is cosecant. So the cosecant of 30 degrees is 2 over root 3. Boom, done. Right? Cosine, secant of 60 degrees is 2. And I haven't done tangents yet, so let's talk about tangent. Tangent of 60 degrees, so fold this finger down, and you have to do, I always think of it as sine over cosine. So it's root 3 over root 1. So tangent is root 3 over root 1, or what most of us would just call root 3, which means that cotangent is 1 over root 3. There you go. Let me ask you maybe a question or two, and then we'll come back. All right. Good attempt on those ones. All right, let's move on. Now, sometimes, like I told you, you're going to be able to draw those, use your hand because it's a 45 or 30 or a 60-degree triangle. But if it's not, you're out of luck. If it's not a ratio you've never recognized from that pattern of fingers, you're out of luck. Calculator's going to come in, or you're going to have to draw a picture. So let's talk about what we do there. Now, if you look at this next example, it says sine is 1/6. That's not, square root number of fingers over 2. So I can't figure out what that is. I'm like, all right, so that's nothing I know. So what I'll do is I'll just come out here and I'll randomly draw a triangle. And so it'll look like this. There's my right triangle, and this my angle. And I know it has a sine of 1/6. That means that the opposite over the hypotenuse is 1/6. So I know the opposite is 1. I know the hypotenuse is 6. Boom, right? Now there's this good guy named Pythagoras, and he has a theorem, and I happen to know it. So I know that a squared plus b squared equals c squared, or 1 squared plus something squared equals 6 squared. So is that b squared equals 35? So this is root 35 right here. Now I'd reduce that if I could, but I can't, so we're golden. And now I will tell you all the trigs. If I already know that sine is 1/6, I now know that cosine is adjacent over hypotenuse, so 35, 6. Tangent is opposite over adjacent, so 1 over root 35. And then cosecant is 6 over 1. Secant is 6 over root 35. And cotangent is just root 35. And I forgot my thetas here, so that's kind of annoying. So I'm sorry. There they are. Now look at the next one. What the heck is cosine of 53 degrees in 25 minutes? I have no idea, right? So that scares me a bit. So I'm going to have to use a calculator. So I will grab virtual Sheila, and she's trying to go full screen. No, Sheila. I just want you to slide over here so I can still see the problem. There we go. Now I want to find cosine of 53 degrees. Now notice I'm saying degrees, and that is actually very important because of the fact that when you hit the mode button, you want to make sure that your calculator's in degrees. And good thing I checked, mine was in radians. So I'm going to go over, I'm going to put it in degrees, and I'm going to quit out. Now I can just go ahead and type this in. I can be like cosine of 53. Now where the heck is that angle button? Oops, there it is. Second apps angle 53 degrees 25, and then I think I have to go in that angle one more time, minutes, and I can close my parenthesis and boom, do the best you can, right? 596, so 0.596 with a little bit of rounding, so it's approximately equal to 0.596. Boom, right? Now look, I'm going to go over to this other guy who is the cosine of pi over, or cosecant of pi over 7. Ooh, that's a little tricky. First off, I don't know pi over 7. That's not one of the ones I know, which are, pi over 2, pi over 3, pi over 4, pi over 6. Okay? It's not one of those. It's pi over 7, so that's a little tricky. I notice it's also in radians, so my calculator better be in radians. So if I go ahead and hit mode and then radian, boom. Now, one thing you want to know is that cosecant is the inverse of sine. So I can also do this as 1 over the sine of pi over 7. So if I grab my calculator, and I'm going to just say, hey, calculator, what is 1 over the sine of pi over 7? And I hope I hit my mode. 2.3. That sounds pretty good. 2.305. Boom. There it is. Done. Calculator love. Like it. All right, what else can we do? What if I ask you to find the exact value? That's, again, dead giveaway. I don't want you using a calculator. You should be able to use your fingers or draw a triangle or something, right? So exact value means a dead giveaway. And so what this is who has a cosecant of 2 over root 3? Wait a minute. If that's cosecant, then a little magic says that sine of x must be root 3 over 2. And if I look at my hand and I try to figure out sines, the bottom fingers, which finger would I have to fold down in order to have root 3 over 2? Well, for me, I'm looking at it, that's my pointer finger. So my hand looks like this. It's like, here's my thumb, and then here's my folded down pointer finger, and then here's my other fingers. Yeah, I know. And so I know, boom, notice right here, I have root 3 over 2. That is a gorgeous drawing of what my hand looks like. And I'm feeling pretty good that I know it's 60 degrees. So I'm like, the answer is 60 degrees. Or pi over 2, pi over 3. Or pi over 3 if you want radians. You let me know. Boom, done. Feeling good? All right, let's ask you a question, and I'll be right back. Excellent work. And should we stop there? Heck no, because now comes the fun part of trig, right? This is the part that you get to go out usually and you do stuff. But let's first figure out how to use these parts that we've figured out, this newfound knowledge, or maybe this review of knowledge that we've had. So here's a triangle, and it could represent any situation. Like I've measured an angle to the top of a tree, and I have a rope to the tree, I don't know, 17 feet long, and I want to know X, how far away am I from the tree? Whatever, who knows, right? But let's figure out how we solve X. Well, it's nice because you have a right triangle, so you know right triangle trig is in play here, and you have an angle. And so you're like, all right. Now, if that's the angle, then real quick, I know that this is the height. I know that this is the OPP, and I know that this is the ADJ. And I look at what I have and I'm like, all right, I got an angle. The ADJ is what I want, and the hype is what I have. And what ratio would use the adjacent and the hypotenuse? Hmm. Wait, cosine. So this is a cosine problem. So like, all right, I know that the cosine of 20 degrees, whoops, that's supposed to be a 0. Cosine of 20 degrees is equal to the adjacent x over the hypotenuse 17. And now I can go ahead and solve for x. I multiply both sides by 17. And lo and behold, I have a very simple problem that I just need to get my calculator out for and get me the answer. So 17 cosine 20. Now I'm going to make a mistake here because what did I not check? That's called 20 degrees, right? I get an answer 6.93. I think I'm cool. Be careful. Mode. Oh, I was in radians. So it just treated that as cosine of 20 radians, not 20 degrees. So let me go down. Let me hit enter. Let me quit out and hit it one more time. Oh, it's 15.97. You see, I could have been totally misled if I'm not careful. So 15.97 whatevers. Now, again, you're only going to have to worry about your mode if you're going to press one of those trig buttons, sine, cosine, tangent. If you're going to press one of those, then I need you to pay attention to the mode. Other than that, the mode never matters. So if you're not pressing sine, cosine, or tangent, don't worry about it. But if you are, I have to worry. All right, last but not least, from a point 300 feet away from the base of a building. So here's the point. Here is my awesome rendering of a building, and it has a roof, and it's got a window, and awning. I don't know why, with a door, and you can walk out and stand on the ledge and wave. Okay, so 55 degrees. Wait, I'm 300 feet away. Got a little carried away there. 300 feet away from the base of the building. Sweet. Angle of elevation to the top of the building. So let's say to the top of the roof. Boom, is 55 degrees. Can we then tell people how high this building is? Well, yes, sirree, we can, right? So I can tell them, all right, somebody's going to argue that it's a little more than 300. So let's pretend that the top of the building was straight across like this, because I don't want that kid to come in and be like, well, and you know which kid I'm talking to in second period. If this is the top of the building here, yes, I'm using the color red, and that's a giveaway. The top of the building now, it's 300 feet away, and the top of the building is 300 feet. So we're good. Now we look at that. It makes a right angle here, assuming the carpenters made it correctly. We can now try to calculate that. And again, I need to use trig. I got to figure out what ratio would I use. Well, to me, this looks like, here's my right triangle. Here's my angle. This is hype. This is the ADJ. This is the OPP. I need OPP and ADJ. That's tangent or cotangent, take your pick. I'm going to say the tangent of 55 degrees is equal to the opposite H over the ADJ 300. And I'm going to multiply that over, and we're going to have 300 tangent 55. We are in calculator ready form. We grab Sheila and we type in 300 tan 55. Make sure you're in the right mode. So it's always a good time to check. Oh, I am. Sweetness. And now I can just hit enter. That building is 428.4444 feet. So 428.4444 feet tall. That's it. Have a great day. Stay happy, and I'll see you tomorrow.